Alright, so today I'm making concentrated acetic acid from just regular vinegar. Yeah, from the weak 5 or 10% acetic acid you can find from the grocery store. If you're going to attempt this at home, make sure you have adequate ventilation, as I'm being totally honest right now, but concentrated acetic acid is like crazy stinky. If you think normal vinegar smells bad, then you're going to regret even going near this thing. However, instead of trying to distill it directly from the vinegar, I'm going to do this by reacting concentrated sulfuric acid with its salt form, or sodium acetate. This can drastically boost up the concentration without the need of distillation, which would be extremely difficult due to the proximity of the boiling points of water and acetic acid, which are respectively 100 and 118 degrees Celsius. It's way more efficient and gives a much purer product in the end. Glacial means at least 99%, so if you want a purity that high, you're better off just buying it. Anyways, I still really like this method and it's worth trying. So let's hop right in. First, I'll start with turning the vinegar into sodium acetate, which I can do by neutralizing it with a base. Any base works, like baking soda, but I wouldn't recommend it as it's messier to work with and creates a bunch of CO2 bubbles. For this one, I decided to just use solid sodium hydroxide pellets, which only creates water and sodium acetate, as you can see in the neutralization equation. If I use baking soda, you can see how the carbonic acid formed on the other side will involve CO2 from its decomposition. Now, one downside of using sodium hydroxide rather than baking soda is that I can't tell when the reaction is finished or if it's even happening. But I do trust the chemistry on paper, so I just calculated the amount I needed. Now for this experiment, I used about 730 mils of 10% vinegar in hopes of attaining close to 100 grams of sodium acetate at the end of this step. If you use 5%, that's also fine. However, just note that you'll need twice the amount of vinegar and it will be more water to boil off as well. Now, according to the stoichiometric calculations, I'll need about 48 grams of sodium hydroxide. Also, just a quick note, you might want the vinegar to be slightly in excess. At least that's how I did it, because having sodium hydroxide might cause the sulfuric acid in the later steps to produce more water via its neutralization. After dumping the entirety of the sodium hydroxide into the acetic acid, the temperature really increased, and it proves how exothermic this is. I decided to use a metal pot, which was a mistake as it becomes an issue later, and you'll see. Now I'll just have to put it on the hot plate and heat it to eliminate all of this water and potentially some vinegar that has been left there in excess. Then I can obtain my pure sodium acetate. Also, you can check if the reaction is neutralized with the help of pH paper, and as you can see here, it's pretty much neutral. You want to heat it slowly, since if it gets too hot, the sodium acetate may decompose. I left it on for a few hours, and when I came back, well, no one could have ever expected this, but a bunch of rust formed and ruined this sample. This was quite disappointing, and it meant that I had to redo it. So this time, I used an actual cooking pot for this evaporation step. Again, I added in the vinegar, sodium hydroxide, and heated it up. Now, after coming back many hours later, it looked like all the water had evaporated off and left me with this huge mountain of sodium acetate. It looks like it all suddenly crashed out at some point and formed this cool hill. Now I can scrape it all out to obtain my sodium acetate and also crush it up a bit into a powder. But wait, something's still wrong with this sodium acetate. It's not actually pure anhydrous sodium acetate, but it's actually its trihydrate form. That means there's still a lot of water incorporated into the crystals. Now, in order to boost the purity of the final acetic acid, I'll have to drive off this water. Technically, this should have been an easy step, but my impatience here caused me to mess it up. To dry it off, all I had to do was heat it up, and yet it seems like the heat was a little too high, and it caused it to actually decompose and form this ugly brown mess. You can see how it's completely charged, and I'm left with this pile of junk. Again, I was really disappointed, but it only meant I had to try again. So yes, for one more time, I dumped into the pot vinegar, sodium hydroxide, and waited. When all the water left, I was again left with this pile of sodium acetate trihydrate, but this time, I'm going to dry it properly. After doing some research, I found this useful video by Doug's lab on the optimal temperature to dry it. He said it should be dried in an oven at about 150 C or 300 degrees Fahrenheit. So I transferred it onto this baking tray and did exactly what he said, leaving it in there for a few hours. Now when it came out, it actually looks like it worked and all the water was gone, as the mass of the powder was under 100 grams, the theoretical yield. So I was basically left with 94 grams. Now for some serious chemistry and the last reaction. I have to take my anhydrous sodium acetate and react the powder with some concentrated sulfuric acid. By the way, gloves, goggles, and good ventilation are required for this step. So for this part of the experiment, since I'll need to be distilling the acetic acid later anyways, I decided to do it in a round bottom flask and have everything in one setup. So I transferred the 70 grams of the sodium acetate powder into a 250 ml flask and made a chunky distillation setup with a Glacial adapter so that both steps can happen at the same time. On the top, I have an addition funnel in which I poured 105 ml of 98% sulfuric acid into. Then, I very slowly add the sulfuric acid into the powder. Immediately, you can see a bunch of dense white smoke rising, and due to how exothermic this reaction is, the acetic acid produced can literally boil itself on its own. So after all the sulfuric acid has been added, you can turn up the heat moderately just to keep the boiling going. Now the dense white smoke is pretty mesmerizing, and it reminds me of that one time when I made benzene. What's happening here is that the sulfuric acid is protonating the acetate ion, essentially pushing it back into acetic acid. This is because the equilibrium vastly favors the right side of the reaction. The production of acetic acid is much more favored rather than sulfuric acid, as acetic acid is a much weaker acid and is thus more stable. Meanwhile, the sodium ion gets left behind in the flask as sodium sulfate, which is just a byproduct of the reaction. You can see in the collecting flask that a good amount of acetic acid collects, one drop at a time. I let the acetic acid continue distilling over, and I collected everything at around 110 to 118 C, or the majority of the distillate was coming over. You can see how as the reaction proceeds, and thus the rising temperature, the vapors coming over become more and more clear, which is a sign of less water. So the white smoke you saw at the beginning actually had a fair amount of water in it. When the rate of distillation slowed down to a halt, I felt that we collected the vast majority of the acetic acid. And yes, this was a pain, but if you look at the hot plate, you can see that the layer of aluminum foil I wrapped on it actually melted, and it was impossible to remove. So if you have any tips, please leave them in the comments. I'm having trouble trying to clean it. Now I was nice and excited to have this high purity acid, so I took a strong whiff of it, and I instantly regret it after. It was so acidic that it completely broke my nose for a bit, and it stung my entire nasal pathway. Like it started to become runny and I couldn't smell anything for a bit. Luckily, my senses were restored after a few hours. I transferred everything into a graduated cylinder for a yield and purity calculation. In the end, I obtained 48 mils of acetic acid, which is literally a yield of 98%. Now at first I really didn't believe it, and I was right. When I stuck it into the freezer, its freezing point was only 1 degree Celsius, meaning it only has a purity of about 85%. Glacial acetic acid is when its purity is 99%, and so it freezes at only 16 C, hence its name. For many purposes, my concentration might be okay. However, I was really curious if I could get it higher. So I tried distilling it multiple times. Seriously, like I tried experimenting for countless hours, and even trying fractional distillation, but I really had no luck in increasing the purity. I think this is because it forms a pseudo-azeotrope, and due to the small 18-degree difference in their boiling points, it's nearly impossible to obtain a high purity with standard distillation setups. Distillation temperature curve would always look something like this, even with a fractionating column, and I just couldn't make it any more pure without losing a significant amount of my yield. Indeed, the last few drops that came over, when they fell on a cool surface, they instantly crystallized, but the significant amount of my distillate was still very impure. Now I've seen other YouTubers able to boost it up to 95%, but I simply believe that this is probably because they have very minimal amounts of water to start in their reagents, and they avoided this problem in the first place. For example, maybe I could have dried my sodium acetate longer, and even used pure sulfuric acid, as my sulfuric acid is only 95 to 98%, and this could lead to a contamination of 2 to 5 mils of water in my final product. Seems insignificant, but it perfectly explains my purity of only 85%. Anyways, I'm still quite proud of what I have obtained, and if you're trying this at home, really make sure no water gets into the reaction. Since you've made it to the end, congrats, and please consider subscribing by clicking the button below. And thanks for watching.